All right, and welcome back. Hope you had some fun since last we saw one another. Hope you also been studying a little bit. Okay, in our last section, we learned mostly about things in the select clause and how we can change around the columns and put in functions and all kinds of other good stuff. In this section, we are going to talk about the where clause. Whereas last time we talked about which columns, the where clause is going to determine which rows are returned for a query. And it's going to do that based on standard Boolean logic. So most of this stuff is going to be real straightforward for you as programmers and or not. This is second nature for you guys. There are a couple of additional operators in SQL associated with set theory, so we'll take a look at those, but this one's not going to be tough for any of you guys. All right, following our standard practice, then please go ahead and download the select script. I think this is lecture 13 selects.txt. Open that guy in your favorite Word pad or favorite text editor of choice, and then fire up developer logging in as my store so we can run some of these scripts. Should be great fun.
Okay, let's look at our very first query for this lecture. Select product description as description, product name as name, and to-car, suggested price, and then a template as price. From products, where product ID is greater than 0, ordered by suggested price. Okay, really we've got two new elements going on here. First is the to-car function with an associated formatting template, and the focus of our immediate discussion is the where product ID is greater than 0 clause. Hey, we're all programmers, so this should be absolutely nothing new. I want all the rows from the products table where the product ID is greater than 0. Hey, since our sequencer started with 1, that should simply be all the products. All right, easy enough. Let's move on to something a little more interesting. Select that same product set from products where product ID is greater than or equal to 0 and suggested price not equal to $3.99, ordered by suggested price. Here we're selecting that same set of columns, but restricting our rows to only those with product ID greater than or equal to 0 and suggested price not equal to $3.99. Hey, come on. You know how this is working. You're all programmers. We've been dealing with Boolean logics every day of our lives. For an AND operator to be true, both conditions must be true, versus an OR operator where either can be true, and of course the NOT operator, which inverts a Boolean value. One more quick example and we'll have covered all the variations on our where clause operators. Select that same stuff from products where product ID not equal to 0 and suggested price less than or equal to any of 2, 3, or 4, ordered by suggested price. Up again, pretty darn easy if you take a couple of minutes to think about it. Give me those same fields from the products table for rows with product ID not equal to 0 and suggested price less than or equal to any of the values in this comma-separated list. By the way, did you notice the alternative not equal operator? Yep, either's just fine. Well, now, how's this thing going to evaluate? Well, we know the first condition will always be true because all of our rows started with the sequencer set to 1. Cool. Let's focus then on the second conditional. Suggested price less than or equal to any of the values 2, 3, or 4. Well, because $3.99 is less than 4, the condition is satisfied for all our products with a price of $3.99, and we should therefore expect to return just those rows. Note, if I had used an all qualifier then instead of the any, then we would have expected no rows returned. All right. Before we move on, let's officially review the where clause operators. Equal, not equal, and please note the two forms we discussed. Less than, greater than. less than or equal, greater than or equal, and then, of course, our two modifiers, any and all. Cool. Now let's go back to that interesting formatting we were doing on the suggested price field. Basically what this says is take the suggested price and convert it to a character string, and then format that string according to that template provided. Hey, do you suppose there are interesting formatting options for date fields too? Well, probably wouldn't have brought it up if there weren't. How about this query? Select sysdate, 2-car sysdate day, 2-car sysdate DDD as Julian, 2-car sysdate D as D1_7 from Dual. Well, apparently it got me writing this script on the 16th of December 2016. The day of the week was a Monday. The Julian date was 3/54, and Mondays are the second day of the week for Oracle Week. Cool. Please note, there's about 1 million other alternatives for formatting numbers and dates. If you have a specific need, I suggest you just Google it, because nobody memorizes all these things. By the way, that's why they call them reference manuals. All right, up to this point, we've really only looked at the standard Boolean operators and their associated extensions. Next, we're going to look at some additions to where we can go to Oracle-specific operators within the where clause. First one we're going to look at is the in operator. This is one of my favorites, and I used it regularly with respect to uncorrelated subqueries such as this one. Select distinct product description as description, product name as name, and suggested price formatted as price from products where product ID is in the subquery returning select product ID from order line items. So what's this guy doing? Well, it's getting a distinct list of all these products ever ordered. Probably a pretty common question. Yeah, what's ever been ordered? All of our products? I mean, people are going to come to you with that question. Let's look through the subquery first. Return the set of product IDs found in the order line items table, i.e. all those products ever ordered. We see here that the list is pretty long, as there is one row for each row in the order line items table. We then select each row from the products table where the product ID of that row is in the set returned by the subquery. Hey, if we are ultimately returning product rows and not their order line item correlates, then why did we need the distinct qualifier in the outer query? Well, actually we didn't. If I'd have done it right, we'd had that distinct on the subquery to minimize the number of rows returned and thus increasing our performance. I'm just messing with you again.
Okay. But Rick, you say, why do you mess with us by intentionally throwing in these erroneous clauses and doing things backwards just to make things life difficult? The answer is no, absolutely not. I want you to start thinking about the result sets associated with a query before you execute that query. I want you to start being able to see errors before you create them. Particularly important when associated with 2, maybe 3 commands. Update and delete. You don't put a where clause on update and delete statements, you're just about to make a mess. Similarly, when we get to multi-table selects, or when we write single table selects against huge tables, and we get the where clause wrong, we can make our database come to a standstill with respect to performance. I can't tell you how many times I've gotten calls from programmers asking me to kill their runaway query. How do you stay away from these things? You think before you click execute. That is, just like when you're coding, you always anticipate how a particular paragraph of code is going to work. I want you to do the same thing with respect to deletes, updates, and any selects with a where clause in it. Understand how that where clause is going to work before you execute. Anticipate the results and then use the execute as a means of verifying that you had it correct. Same thing as though you were debugging a program. You anticipate that your code is correct and you look for anomalous situations. I want you to do that same thing starting going forward from here on out. Never hit the execute until you are certain in your head how that query works. All right, I'll get off my soapbox, but please understand how important that one is.
All right, I'm off my soapbox. But trust me, I've had to go in and kill enough runaway queries to know that everybody doesn't follow that practice of knowing what to anticipate before you actually execute. All right, anyway, moving on. Next, let's look at the like operator. The like operator does string pattern matching. It has two corresponding matching methods. The underscore matching against a single character, whereas the % matches against any number of characters. Hang in there, guys. A simple example is going to clear this right up. Select our regular stuff from products, where product name is like, % Barry, %. Basically saying, give me my standard list of columns where product name like, % Barry, %. In other words, the string of characters, Barry, must be somewhere in the product's name. Okay, results are just what we've expected. What about this one? Select these same columns from products where product name like, %BE underscore Y %. Now we have replaced the R's in Barry to the underscore single character match. If we had a product named Belly, would that row have been returned? Yes. Yes, of course. All right. Our last where clause operator is going to be the between operator. We'll do an example where we use the not modifier. Again, we're all programmers here, so not logic should be absolutely no problem. Select our regular stuff from products where product ID not between 1 and 3 or product name like, and then we've got a %JA %. Okay, here we've added the product ID column because otherwise the top is the same. The where clause reads product ID not between 1 and 3, which basically reads the product ID will be equal to 4 or 5 because our operator is inclusive. To those rows we'll add any which have a JA substring in their name. In our case, that means the word jam. All right, the result set is just as we'd anticipated. The true rows associated with product IDs 4 and 5, and then our 2 rows associated with jam in their name. Note, we knew what we expected before we executed this query, the correct order of doing things in SQL.
All right, that puts a wrap on single table queries. We are moving along, guys. 4 more lectures on queries and then a little PLSQL, and we're going to call this thing a wrap. I'm getting so excited. All right, so what did we learn in this one? Hey, where clauses are easy. Standard Boolean operators we're all used to: equals, greater than, less than, greater than or equal to, less than or equal to, not, all, and, any, or. You know, these are very simple and straightforward things for our people who have been programming for a long time. We then took a look at reformatting some of our output through the two-car and a template methodology. Again, I don't suggest you try to memorize all these. That's what reference manuals are for. We don't use them on an often enough basis to worry about that. You just fire up Google when you want to know what's the template associated with Julian date. And, by the way, it's DDD. All right, we then ran a query where a distinct query with a little subquery thing, where I intentionally put the distinct on the wrong set. I did it to make a point. I want you guys to start thinking about the results before you execute a query. Know what to anticipate and then validate those results by executing it, not the other way around. We then looked at some of the SQL specific extensions For where clause operators, more particularly, we looked first at the in. One of my favorites because I use it as a test against a uncorrelated subquery. We'll talk about that coming up here in a couple lectures, but it's hugely important way to get results. We also looked at the like operator, where we basically did a string matching situation. We had the underscore, where we did a single character match, versus the percent sign, where we did a multi-character match. Again, very easy stuff. We'll get to regular expressions, but that's a couple of lectures down the line as well. But yeah, they're out there, so we can anticipate those coming down the pipe as well. We concluded our discussion with the between operator and also not. Again, none of this stuff is even close to exciting for programmers because it's stuff we should already all know. It's just a matter of learning the proper syntax. So that's all good. And now we're ready to tackle joins in the next lecture, where things are going to get a lot more interesting. So I look forward to that. We'll see you at that time. And in the interim, get out and play. But learn something every day.